Okay, so we do application of determinant today. So we are doing inverse of using cofactors and cofactor matrix adjugate terminology, which is adjoint is the same, and Cramer's rule today. All right. Previously we have the matrix A is inverse, which is a square matrix, right? Then we have this one. And we have another definition today about the cofactor matrix. So we have let A equal to this entry or element be n by n matrix. Then the cofactor, it's not the cofactor expansion, it's the cofactor matrix, right? Matrix of A, we denote, oh my gosh, this is like that. Cofactor matrix A, and this one we can use cofactor, see, again, already. Cofactor matrix A, IJ, so IJ entries, right? We cross out where cofactor A matrix IJ is the ijth cofactor of cofactor factor. Oh, that was correct, right? Factor, I'm crazy. Okay. Okay. So we know that, right? When we denote cofactor with the subscription means we cross out, right? So
when you write ijth, do you always put an e at the end like that?
IJ what?
When you wrote ij is the ijth cofactor of A, you meant to put just a little th, right?
THE, correct. Yes. Yeah. Thank you. Here, right? Yes.
It's just a little thing.
Yeah. Thank you. Cross. Yeah. Hold on 1 second. Cross out first because same color. Hold on. Then IJ. Thank you very much. Okay. So we're gonna use a cofactor matrix later on. Okay, now we have another vocabulary which is adjugate. So look, adjugate. Adjugate. Or other book indicate that adjoint. Okay, if we have matrix 2 by 2, A, B, C, D, right? Okay, how do we indicate adjugate, adjoint? That's why they have ADJ, it's the same letter, ADJ, right? So adjugate of A. All right, look. We switch over, then we give it to the negative. And switch over, right? Maybe we put here. So we get the A and negative B and negative C. That is correct, right? Adjugate or called adjoint, all right? Okay, let us do this. We have inverse and determinant. How do you find the inverse? Let me just use this one. Theta 3.4.1, the inverse, and the determinant. So we have determinant of A is not equal to 0, right? So we have inverse of A, which is 1 over determinant of A, because we don't want undefined. That's why. And we have adjugate of A. All right, so we're gonna find okay, so let's see. Also, we can express adjoint, adjugate of A. It's the same as a the transpose of a cofactor of A. All right. So in that case, it's 2 by 2. In that case, we have more than 2 by 2. So 3 by 3. We can use that. All right. So let us do example. Find the inverse of the matrix. So we are using this formula, right? So we have 1, 2, 3, 3, 0, 1, 1, 2, 1. Okay, now. So let's see. We are using 1 over determinant of A and adjugate of A. All right, so adjugate of A, also we can have transpose of a cofactor of A. Let us do this one first. What should I do first? Determinant of A first, or okay, let's follow just books process. Okay, let us find the determinant of A first. We had the experience before, so we are using REF. But in that case, already one entry is in the first row, so maybe we can make an upper triangular matrix, right? Create upper triangular matrix. Okay, how about everything? Just now. Change mode. Copy. All right. Okay, so we want to make a 0 here. How do you make a 0?
We could subtract 3 times of one of the other rows.
Good job.
Hmm.
All right, so we get 0, -6, -8. Okay, how about thank you. Cramer says, how about we want to make a 0 here?
Just subtract row 1 from it.
Okay, good job. So 3. Okay, so we get 0, 0, -2. Very good. Thank you, during message. Okay, so in upper triangular matrix, we can make the diagonal product, right? So, oops. So determinant of A, which is 1 times -6 times -2, what do you get?
12.
12, good. All right, now we have this one, 1/12, right? Okay, adjugate, we want to find cofactor of A and then transpose, right? So let us do that. Adjugate. Transpose of cofactor of A. Okay, so a lot of work. Let us using cofactor of A and 1, 1. So we cross out, let me see. So we cross out row 1, column 1, right? So we get, all right, so sign, we need to deal with the sign, 1 plus 1, yeah, positive. Okay, now we have 0, 1, 2, 1. So we multiply this way, positive and 1, I'm sorry, 0 minus 2. 0 minus 2, which is -2, right? Okay, now cofactor of A, 1, 2. We have a positive and then we get negative. And then 1, 2, 1, 2. Oops. 2. So we get 3, 1, 1, 1. Please correct me if I make a mistake. It's negative. And we multiply this with 3 minus 1, which is -2. Yes, good. Now, cofactor of A, ooh, already tired. 1, 3. So negative and positive, right? Positive. So positive. No, write down positive. Okay. So we will get 3. So we will have 3, 0, 1, 2. Multiply, so 6.
Were you
Okay.
saying if you have if you for the exponent with the -1, if you have a even like a positive, you're just not even gonna write it down? Is that what you're
Yeah, because it's just 1, right?
just 1? Okay,
Yeah.
yeah.
So basically, since we had the experience earlier, right? We did the last time cofactor expansion, right? So always sign is positive, negative, right? So we don't have to write down the power, right? Because that takes time too, right? Okay, so we have that. Now we move to row 2, so cofactor of A to 1. We had earlier positive, it's negative, right? Okay, 2, 1. Let me just use in black. So 2, 1. Okay, so we get 2, 3, 2, 1. Multiply, so negative 2 minus 6, which is negative positive 4. Good job. Thank you, direct message. Okay, cofactor of A, 2, 2, negative, so we get positive. And 2, 2. So we get 1, 3, 1, 1. Good, thank you. 1, 3, 1, 1. Okay, so there will be 1 minus, this is 1 minus 3, which is negative 2. Excellent. Thank you, direct message. Okay, now cofactor of A, 2, 3. It's a positive, and then we get negative. Then 2, 3. So we get 1, 2, 1, 2. So we get negative 1, 1, 2, 1, 2, right? Which is 0. All right. We move to row 3. Cofactor of A, 3, 1. So negative is positive. And then three and 1. 2, 3, 0, 1. Thank you. All right, so we have 2, good. And cofactor of A, 3, 2. All right, so 3, 2. Sorry, sign. We have a positive, so we get negative. 3, 2. 3, 2. 2. 1, 3, 1, 1. Thank you. Okay, negative 1 minus 3, which is positive 2. Okay, now cofactor of A, last one, 3, 3, negative, so we have a positive 3, 3. Which is 1, 2, 3, 0. So we get 0 minus 6, which is negative 6, right? I did not make a mistake. Did I?
The 3, 2 matrix is 1, 3, 3, 1, not 1, 3, 1, 1. Yes, 1, 3, 3, 1. Yeah. 1,
3, 3, 1. All right, 1, 3, 3, 1. Correct. Thank you. So this one. Okay, then this will be 1 minus 9.
Yeah, 1 minus 9 will be positive 8. Yeah, final answer.
Okay, positive 8. Thank you very much. All right, so there is a row and column. So we're gonna put this one, first row, first column, right? This one, first row, second column. So there is a position, right? So let's see. There will be, this is cofactor matrix. So we have negative 2, negative 2, 6, and 4, -2, 0, 2, 8, -6. Please correct me if I make a mistake. Okay, now adjugate is the transpose of that. So that will be row to the column. So -2, -2, 6, 4, -2, 0, 2, 8, -6, right? Let's adjugate. All right, now. We do 1/12. We lost. So hold on 1 second. Do again. We are using inverse. This one. Now. So this will be 1/12. So adjugate, that will be adjugate. Okay. So there will be 6, 3, 6, 6, 6, 3, and 2, 0, 2. Is okay? -6. Yeah, very good. Okay, we can check that whether A and inverse of A gives the identity or not, right? So same, right? So we can check either one. Maybe where's A? A is there. Hold on 1 second. Maybe we can ask TA. Oh, wow, he checked already. Identity. Okay, good job. So that is, thank you very much. TA. So, which is identity 1 0 0 0 1 0 0 0. All right. Okay, so let us talk about Cramer's rule. Okay, so we have the system of equations. Cramer's rule. This is method we are looking for the x. Yeah, so other method to find the solution. Okay, we have a system of linear equation, and they're using AX equal to B. So in this book, they're using this one as a column vector. This is a column vector. Okay, so if we have AX equal to B, and A is matrix, right? So let's say that A is a square matrix. Square A. Okay, now let's multiply inverse of A both sides. So there will be A inverse, right? So that will be, we have AX equal to B, right? Okay, then we can express this one by associative. This will be A inverse A, X equal to A inverse of A and B, right? Okay, then we know that this will be I, X equal to inverse of A, B. Then we can express inverse times X, which is X, right? So we have X equal to inverse of A, B, right? So that is the one. So look, we are using Cramer's rule. Hold on 1 second. So we had X equal to inverse of A. We can express this way, right? So 1 over determinant of A, right? So this one, we can express that. And B. But then look, A inverse, earlier we had a formula. A inverse, which is 1 over determinant of adjugate of A, right? This one. So we can use this one whole thing there. And B. How about parentheses? Yeah. Oops. And B. Okay, so A inverse. Using that. Okay, now I want to make Cramer's rule directly. If we have a 2 by 2, Cramer's rule. 2 by 2 matrix. So we have, let me see. Let A is B this one first. A invertible. And by A matrix. And we have a unique solution. Is AX equal to B. X equal to column vector this way. And B equal to, they're using column matrix. B1, B2, B7, matrix. Okay, now we are replacing the Cramer silver setup. X sub I equal to determinant of A sub I B over determinant of A I equal to 1, 2 until n, right? Now, if A equal to 2 by 2 matrix, okay, so we are using the B column matrix in front, and we shift, right? So let me say A sub 1 equal to B1, B2, and A12, A22, A2 equal to A11, A21, we shift to B, which is B1, B2. Okay, how about 3 by 3? Equal to 3 by 3 matrix. So we have A equal to just A sub 1 first. The first column will be B1, B2, B3. And A sub 1, 2, A sub 2, 2, A sub 2, 3. Shift, right? Everything. And A13, A23, A33. Okay, A2. The B1 will be second column, and we get 1, 1. We have a 1, 2, 1, 3. B will be B1, B2, B3, second column. And then third column, 1, 3, 2, 3, 3, 3, right? So B will be first column and then shift to the second column, right? And then will be shift to the third column. So third column B1, B2, B3, and then same spot, 1, 2, and 1, 3, A2, 2, A2, 2, I'm sorry, 2, 1, A3, 2, right? So can you see that? B1, B1, B2, right? And B1, 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 right? if we have a 4 by 4, then first column is B1, second column will be B1, B2, B3, B4, and third column, and fourth column, right? That's how it works, Cramer's rule. Okay, so let us do this. All right, so we have use Cramer's rule to solve the system. Okay, we get 3x1 minus 2x2 equal to 6. So negative 5x1 plus 4x2, no, that's 2x. How about, yeah, just using that. Okay, so this is 3, negative 2, negative 5, positive 4, and x of 1, x of 2, which is 6 and 8, right? Okay, now let me bring this one. So this is B1, B2, right? So there will be 6 and 8, and A12, A22. So we have a 3, negative 5. Okay, 2 by 2. So we make this way. So negative 30 minus 24, what do we get? Oh,
Negative 54.
hold on 1 second. I made a copy wrong. Hold on 1
Uh-oh.
second. Copy wrong, yeah. Copy wrong. What did I have that? So we get 6 and 8, correct, right? And 1, 2, so sorry, 1, 2, sorry about that. 1, 2 is not right. 1, 2, 1, 2. Because first column occupied by B, right? That's why we are using 1, 2, 2, 2. Make sense? Yeah, good job. Good thing we cut up. All right, so we have a negative 2, 4. Okay, so we multiply this way. So this will be 24 minus negative 16. What do you get? It's a positive 40. Thank you, Determinant says. Okay, so x of 1 will be that okay, so determinant of s of 1, s of 1 of b, we get 40, right? Over what's the determinant of a? So let's see. What is the determinant of a? So 3 times 4 and 10, we get 2. All right, so that is a 2. What do you get this?
20.
20. Thank you. All right. So x sub 2, we get, oh, hold on 1 second. We have to work through. Okay, x sub a sub 2, which is, we are using this one. Okay, we have a b sub 1, b sub 2, which is 6 and 8. And a sub 1, 1. A sub 1, 2, 3, and negative 5. So 24 minus plus 30, right? Can you please calculate?
That's 54.
Thank you very much. Okay, so we have this one. Okay. These two. So we have a determinant of A, which is 2, and determinant of A sub 2, which is 54. Which is, thank you, direct message, 27. So we have the solution x sub 1 equal to 20, and we have x sub 2 equal to 27. Very good. Let us do a 3 by 3. So solve. Solve by using Cramer's law. Okay, so we have 3x minus y equal to negative 2, negative 7x plus 2y plus z equal to 0. We have a negative 6x plus a 4z equal to 1. Okay, so there will be 3, negative 1, 0, negative 7, 2, 1, and negative 6, 0, 4. And this is x, y, z equal to b, which is negative 2, 0, 1, right? Okay. Determinant. Oh. So determinant of A sub 1. Okay, let us using that. This one, right? So we are using B sub 1, B sub 2, B sub 3, that is negative 2, 0, 1, and A1, 2, A2, 2, 3, and 1, 3, 2, 3, 3, 3, right? So we are using negative 1, 2, 0, 0, 1, 4. Okay, this is a 3 by 3. So let us make a cross out, right? So we will cross out that. So we factor out with the negative 2, right? 2104. Okay, now second one. -1. Okay. All right, so maybe we need to deal with a sign, yeah? Or we can try out plus minus easily too, right? So this is plus minus plus minus plus minus plus minus plus, or like a sign what we had earlier. So -2, so -2, 1 plus 1, which is positive, right? So there is a the positive one. We don't have to write that, right? Okay, second is negative. Thank you very much. And -1. And we cross out. So there will be 0, 1, 1, 4. And third one is positive, which is 0. Excellent. 0 is always good. Okay, now let us do -2. A minus 0, positive 1, 0, 1. What do you get this one?
A -17. I think.
-17, thank you. Okay, determinant of S sub 2. Okay, so we figured out to be as the second column. So it's a -2, 0, 1. And let's see. Okay. Thank you, doing the sense. Okay, so A sub 1, okay, let me see yours. Okay, say thank you. So we have 3, -7, -6, 0, 1, 4. Okay, now still plus minus, right? So plus minus plus, yeah, that is the easiest one. Okay, so we get 3 and cross out. So we get 0, 1, 1, 4. Oops, different color. 0, 1, 1, 4. And minus 2. And cross out. So we get -7, 1, -6, 4, and then rest is 0. Good. Okay. So 3, 0, -1, plus 2, -28, plus 6. Please calculate. Thank you very much. It's a -47. Good job. All right. So determinant of A sub 3. So we have that. Copy. So we have this. Okay, determinant of A sub 3. Now, so column, third column for B. So we will get, okay, let me just using here, -2, 0, 1. Oh, there we go. Thank you, different message. I can use yours. -2, 0, 1. There is from the B. Oops. Okay, now A sub 1, 1. 3, -7, -6, -1, 2, 0. All right, now. Why the... Okay, so positive. Let's just do that. Or we can do any 0, right? So maybe we can do a second one. Okay, because 1 is 0, right? So let us do that instead of a first row. So positive, negative, positive, negative, positive, negative. So -7, -7, and what's up? So we get -1, -2, 0, 1, and +2. +2, so we cross out. All right, so we get 3, -2, -6, and +1. Okay, so we get +7. So we will have a -1 plus 2, 3 plus 12. Can you please calculate? -25. Thank you very much. Okay, we found everything, right? But we need to find the determinant of A, right? So determinant of A, so we need A. How about this? It's A. Okay, so determinant of A, so positive, negative, positive. So we will get 3, cross out. So we will get -1, no, -1, 2, 1. Thank you very much. Direct message. And -1. And cross out. So we have -7, 1, -6, 4, and the rest is 0. Okay, now we have 3, 8, +1, -28 plus 6. Can you please calculate? Almost done. Oh. What do you get? Good. Thank you so much. All right, so we have x sub 1, which is the determinant of a sub 1 b over determinant of a. They're using x, y, z, right? So we have a 2 and a sub 1, which is negative 17. Thank you, the wrong message. So 17. And y equal to determinant of a sub 2. Determinant of a, so there's a 2. We have 2, which is negative 47. Negative 47 over 2. Z, which is determinant of a sub 3. B over determinant of a. So we had the last one, not last one, negative 25 and over 2. Good job. Okay, and the direct message, thank you for confirming my work. All right, any question? Okay, then thank you for coming. You have a nice evening.
All right,
I'll see
thank you.
tomorrow.